In this class, now I am going to explain you basic differentiation. Before going to start this class, I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Now let us go to the class. Do you know the meaning of derivative of a function? Derivative, which means that slope of a tangent which is drawn to the graph of the given function. This is the fundamental meaning of derivative of a function. First, I would like to give you the meaning of derivative of a function. Derivative of a function which means that slope of a tangent which is drawn to the graph of a function. You know, in the mathematics there we have infinitely many functions. Every function has its own graph. You know, we have logarithmic functions, exponential functions, inverse functions, trigonometric functions, algebraic functions, composite functions, many more functions we have. So every function has its own graph. So for that graph you can able to draw the tangents. So that tangent slope represents derivative of a function. But you may ask me, what is the meaning of differentiation? Okay, differentiation means the process of finding derivative of a function is known as differentiation. What it is? Process of finding derivative of a function. Actually, our journey begins with first fundamental principle of derivative of a function. We find the derivative of a function by the first fundamental principle of derivative. I explain you that formula. With the help of that formula, we have to find the derivative of every function. But doing the derivative of every function by that formula is so difficult. Hence, our mathematicians have been introduced some methods like UV rule, U by V rule, U plus or minus V rule, chain rule, substitution method of derivative of a function, logarithmic type of differentiation, parametric type of differentiation, derivative of implicit functions, and doing the derivative of one function with other function, like higher order derivatives. So some methods are there. Why they have introduced? Because finding the derivative of a function by the first fundamental principle is so difficult. Hence these methods have been introduced. So in this class, just now I would like to concentrate on basic things. So if you are well known that basic models, then we people can able to go for higher order applications. Now let us go to the derivation of first fundamental principle of derivative of a function. See, let us take a function y equal to f of x. See, draw whose graph? X, x dash, y, y dash. So this is origin. Now, see, I have drawn graph of this function. This function may be a logarithmic or exponential or algebraic or trigonometry, whatever it may be. This is graph of this function, rough diagram. Let us take y equal to f of x. On this graph, take any point, this point, x comma f of x. You know, this is abscissa of this point, and if you substitute abscissa here, you will get respect to y coordinate, ordinate. Now, from here to here it is x. From here to here it is f of x. Now here take a point over here. From here to your x, from here to your h. Okay, if you take this is h, then this point coordinate will be x plus h comma f of x plus h. Now connect these 2 points and extend it. So what you people have got? A secant. What it is, students? Secant. So on the secant we found 2 points. One is x comma f of x, other point x plus h comma f of x plus h. Now find whose slope. So how do you find when you know 2 points on the line? By applying difference of y coordinates. F of x plus h minus f of x. Difference of y coordinates by difference of x coordinates. X plus h minus x. Now both of them cancel. Now you got slope of secant. But what did I say? Differentiation is nothing but slope of a tangent. When the secant becomes a tangent, whenever the secant, see here, I am fixing this point here itself, I am bringing the secant to the down. Like this, like this, like this. Keep this point here itself and bring down that secant. So I said to you, from here to your x, from here to your h. What do you want? You can leave.
No. Okay. Bye. Bye, guys.
Right. Okay, keep this point here itself and bring this down. If you bring this down, what is happening? This point came here, this point came here, this point came here. Okay, this h value is tending to 0. As I said to you, from here to your h, x, from here to your h. So this h is gradually decreasing. Whenever h approaches to 0 or h tends to 0, the slope of secant becomes slope of the tangent. So f of x plus h minus f of x by h. What it is, students? Previously this was slope of secant. Whenever h tends to 0, the slope of secant becomes slope of tangent. So this is denoted by f dash of x. Otherwise it can be written as dy by dx. So this is the first fundamental principle of derivative of a function. Already while I was teaching you differentiability of a function, there I taught to you this one as right hand derivative of a function, because we have bring this secant down towards the right side of this point. Hence we said there right hand derivative of the function. So we kept this point here itself. We took the secant there like this and we used it to bring down like this. This right hand secant, left hand secants coincident whenever h approaches to 0. Hence I said to you there derivative of the function is possible. Differentiability of the function is possible. Because LHD equal to RHD we got. But here in this differentiation not required. Just you remember like a standard result. With the help of this right hand derivative of the function, you people can able to find derivative of every function. But doing this formula is so difficult. Hence we follow the methods of derivative of a function. So now I explain you 1 or 2 problems based on this formula. Then later on I will go for methods of derivative of a function. Right. Now let us see derivative of a function e power x with the first fundamental principle of derivative of a function. See, f of x equal to e power x. You can also take it as y. Now what do we want here? Dy by dx equal to how much? So this is also denoted by f dash of x. Now derivative of e power x is e power x only. If you open the book, you will find the formula d here. Given function is the exponential function e power x. Then whose derivative also e power x. Okay, how it came? By the first fundamental principle of derivative. How it will come, I will show you here. So here, what is that formula? F dash of x, or it can be written as dy by dx. So limit h approaches to 0, f of x plus h minus f of x by h. Now in which, see, what is the given function? E power x. So in the place of x, write e power x plus h minus f of x means e power x by h. In the next step, students, observe me what I am going to do. Limit h approaches to 0. So this numerator e power x into e power h you can write. E power x by h. So from the numerator, what do I take common? If I take e power x common, and I can keep outside. If I write outside, so your limit h approaches to 0, e power h minus 1 by h. So this will be left after taking e power x outside. You know, this is going to be 1, which you learnt in the limits chapter. E power x into 1, which becomes e power x. Now you got now? The derivative of e power x is how much? E power x only. Okay, students? Now, let us go to one more function. Find the derivative of a sine function. F of x equal to sine x is given. As you know, whose derivative? F dash of x. If you open the book, you will find sine x derivative as cos x. But how it will come? By the first fundamental principle of derivative only. See, for example, see, apply that formula. Limit h approaches to 0, f of x plus h. In the place of x, x plus h is getting sine of x plus h minus f of x. F of x means sine x whole by h. Okay? So in the next step, students, observe me. This is looking like sin c minus sin d. Sin c minus sin d can be written as 2 cos c plus d by 2. 2 cos c plus d by 2. Now x plus h minus x by 2. 2 cos c plus d by 2 into sin c minus d by 2. Now x plus h minus x by 2 whole by h. Okay, students, in the numerator, which looks like sin c minus sin d, which means that, so 2 cos c plus d by 2 sin c minus d by 2. Okay, c plus here, plus will come, c plus cos, this is c, this is d, c plus d by 2 sin c minus d by 2. You know, you learnt this formula while you were learning transformations of trigonometric functions. There you got sin c minus sin d is equal to 2 cos c plus d by 2 into sin c minus d by 2. That formula I have applied in the numerator. So these two gets cancelled. Now this is left. So this 2 I am going to bring to the down. When it comes to the down, limit h approaches to 0. Here what is left? Cos of x plus x, 2x here plus h by 2 into this. I can write here also, you know, limit h approaches to 0. Here sin h by 2 is left, by h is there. This 2 I am bringing to the down. When it comes to the down, already here h is there, which becomes h by 2. Okay, students. Now, So when h approaches to 0, when you divide both sides with by 2 also, h by 2 approaches to 0. So this looks like a standard result which you learnt in the limits chapter. Limit x approaches to 0 sin x by x, which becomes 1. So this is going to be 1. If it is 1 and in the place of h write there 0. If I write 0 here, so then cos of 2x by 2 will be left to 2 cancel. Now which is equal to cos x. Now what is the derivative of sin x? Cos x. So this is the reason behind it. But doing the derivative of every function like this is lengthy, no? Hence some functions derivative we evaluate by the standard results, and for some functions we follow the methods of derivative of a function. Okay students, so just I have given you 2 examples how to do the derivative of a function by the first fundamental principle of derivative. Okay students, now let us go to some standard results. That results will come from this formula only, but we don't do derivative of whose functions by this first fundamental principle. Just you people have to remember like a standard results. Standard results. See, function and whose derivative. Okay, so this is the function, name of the function, and whose derivative, dy by dx, f dash of x. For example, if you take e power x, then whose derivative will be e power x only. Suppose if you take logarithmic function, remember in the entire calculus you would have to do natural logarithms derivative. Base should be e. So whose derivative? 1 by x. Now a power x, where a is positive. So then whose derivative becomes a power x into log a. Okay students, suppose if a mod function is given, whose derivative where x is not equal to 0, mod x by x. Next, if you take sin x derivative, sin x trigonometric function, whose derivative? Cos x will come. Cos x derivative minus sin x. Next, if you take tan x, whose derivative is secant square x. Secant square x. Next, cot x derivative minus cosec square x. Okay students. Next, if you take secant x, whose derivative is secant x into tan x, and cosec x minus cosec x into cot x. Next, cot x derivative minus cosec square x. Okay students, so these are derivatives of basic trigonometric functions. So even here we have hyperbolic trigonometric functions also. You can remember like a standard results. Sin hx. Sin hx derivative cos hx. Cos hx derivative, like you will get sin hx. Tan hx derivative, you will get tan hx derivative minus tan x derivative, here you will get minus secant x square x students. Tan hx derivative is plus secant x square x dx you will get. plus secant h square x. In the basic trigonometry also tan x derivative secant square x. In the hyperbolic trigonometric function also tan hx derivative is secant h square x. Cot hx derivative also you will get as minus cosec h square x. In the basic trigonometry also, students, okay, cot x derivative minus cosec square x. In the hyperbolic also minus, okay, but in the basic trigonometry cos x derivative minus sin x, but in the hyperbolic plus will come. Sin x derivative sin hx derivative cos hx, cos hx derivative sin hx, tan hx secant h square x, cot hx minus cosec h square x. Next secant hx, okay, next cosec hx. In the basic trigonometry secant x derivative secant x into tan x, but whereas in the hyperbolic trigonometric function secant hx into secant hx into tan hx. In the basic trigonometry cosec x derivative minus cosec x into cot x. In the hyperbolic also minus cosec hx into cot hx. Okay students, I hope you have understood these formulas. Okay, now let us go to the inverse trigonometric functions derivatives. Sin inverse of x derivative is 1 by root of 1 minus x square. You know your condition for x. Close interval of minus 1 to 1. So, in the cos inverse of x. So, same, but here minus will come. Tan inverse of x derivative 1 by 1 plus x square will come. Derivative of tan inverse of x. Remember, like a standard results, students. Here condition for x is close interval of whose domain minus 1 to 1. Okay, here also close interval of minus 1 to 1. But here x belongs to any real numbers. Now, cot inverse of x derivative. Cot inverse of x derivative minus 1 by 1 plus x square you will get. Next, secant inverse of x derivative. So, 1 by mod x root of 1 minus x square. Now, cosec inverse of x square, x, minus 1 by mod x root of 1 minus x square. So here, when x is smaller than minus 1, here you will get minus. If you open this, you have to write plus or minus. When it is minus, when x is smaller than minus, you know the domain of secant inverse of x. X belongs to minus infinity to minus 1, but here actually you have to put open. Okay, in the domain of secant inverse closed, but in the inverse trigonometry you have to write open. Union. Okay students, see, otherwise you can write closed. Here 1 to infinity. But when x is smaller than minus 1, you have to take here negative. If the x is more than 1, you have to take positive. Otherwise you remember like this. So these are the derivatives of inverse trigonometric functions. Now let us go to derivative of inverse of hyperbolic trigonometric functions, like sin h inverse of x is 1 by root of 1 plus x square. Next, cos h inverse of x 1 by root of x square minus 1. Next, tan h inverse of x 1 by 1 minus x square. Even cot h inverse of x also same, this much only you will get. Okay students, cot h inverse of x also derivative will be 1 by 1 minus x square only. 1 by 1 minus x square only. Next, derivative of secant h inverse of x. Derivative of cosec h inverse of x. So secant h inverse of x derivative amma. So you get as minus 1 by x root of 1 minus x square. Cosec h inverse of x is, so here minus 1 by mod x root of 1 minus x square. Okay students, all these formulas you will find if you open your conceptual understanding books. You remember like a standard results, but proofs are there behind it. So in my previous classes I taught to you use proofs also, while I was explaining you inverse trigonometric functions and hyperbolic trigonometric functions. Very nice classes were there in my channel. Go through this inverse trigonometric functions classes and hyperbolic trigonometric functions classes. There I gave you more clarity about the function and whose domain and whose principal domain and whose ranges and whose graphs, and whether that functions are even or odd or periodic functions or not periodic functions, and how to do the derivative of the function and how to find whose integration. Like very much clarity I gave you in that classes. So for more clarity, you people have to go through my previous inverse trigonometric functions and hyperbolic trigonometric functions classes, which are very important in competitive track. Okay students, but in this class just I am focusing on basic derivative of a function. Okay, so some functions derivatives we evaluate by the standard results. You have to remember like a standard results. Right, now let us see an example for, okay, UV rule. UV rule. UV rule means function will be given like this: f of x equal to x into sin x or x square into sin x. It is algebraic function. This is trigonometric function. Then evaluate whose derivative? F dash of x equal to UV rule amma. This is u, this is v. Keep it aside. So d by dx. See, shall I write the formula here? D by dx of uv, which is equal to u keep outside to do the derivative of v, plus v keep outside to do the derivative of u. This is the formula for derivative of a function which is given as product of function here. This is algebraic, this is trigonometric. Both are different, but between them multiplication operation is there. Treat this as u, treat this as v. Now keep u outside to do the derivative of sin x. Now keep sin x outside and do the derivative of x square. Now x square, sin x derivative is cos x. Now here sin x keep outside and x square derivative 2x. Now this is the derivative of x square sin x. UV rule. Suppose u plus or minus v is given. U plus or minus v. Then here it is y. Now dy by dx equal to du by dx plus or minus dv by dx. Directly you can write. No changes in the sign here. Plus or minus only will come. If it is plus, in the derivative also you have to take plus. Here it is minus, in the derivative also you have to take minus. See, for example, f of x equal to e power x plus cos x. Now what is its derivative? So e power x only. Cos x derivative minus sin x. Leave like this. Now let us go to u by v. If a function is in the form of u by v, u by v rule. Okay, so d by dx, we are doing derivative of this function with respect to x. U is a function, it is there in terms of x. V is a function, it is there in terms of x. U by v. We keep outside du by dx. And u keep outside dv by dx by v square. Okay, right. Okay students, I hope you have understood this formula. Remember, like a standard result. Now let us see a application based on this. Now f of x equal to 2x minus 3 by 4x plus 5. So this is u, this is v. Now apply the previous formula, f dash of x. So this v you have to write as it is here. And do the derivative of v. D by dx of 2x minus 3 minus. So now keep u outside. Do the derivative of 4x plus 5 whole by v square. 4x plus 5 whole square. Okay students. V into du by dx minus u into dv by dx by v square. Now 4x plus 5. So this is constant. Constant derivative 0. And x derivative 1. This is constant. Remember, like a standard result. Derivative of constant. Derivative of constant. Constant means no variable. Fixed values whose derivative becomes 0. So here there is no variable in the second term. Hence whose derivative is 0. Here x derivative becomes 1. Here 2 you will get. Minus 2x minus 3. Derivative of 5 is 0 and the derivative of x is 1. 4 whole by 4x plus 5 whole square. Now multiply 2 with these two. 2 4s are 8x. 2 5s are 10. 4 into this minus 8x. Minus into minus plus 12 by 4x plus 5 whole square. Okay students, I hope you have understood. These two gets cancelled. Now which is equal to, so 10 plus 12 which becomes 22 whole by 4x plus 5 whole square. Okay students, 10 plus 12, 22 by 4x plus 5 whole square. Now you got the derivative of this given function. Yes, this is u by v rule. Now let us go to discuss chain rule. Chain rule. So I am going to give you an example for chain rule. A function is given like this. F of x equal to log of secant x plus tan x. F of x equal to secant x plus tan x. Now do whose derivative? Do whose derivative students? See, actually f dash of x. In the standard results which you learnt. So here if you treat this is x, log x derivative, in the base nothing is given means e. Here it is natural logarithm. So do the derivative of this function. So if you treat this is x, then it will become log x. Log x derivative 1 by x. 1 by secant x plus tan x. Log x derivative 1 by x. Is this x? No. Hence you have to follow the chain rule. If it is x, you have to leave like this only. So this is not x. Again, it has to be derivated. So d by dx of secant x plus tan x. This process you have to continue until you get x. So here secant x derivative secant x into tan x, as you have studied standard result. Tan x derivative secant square x whole by, in the down, secant x plus tan x. So from the numerator, what can be taken out? Secant x. If I take secant x outside, so here tan x will be left. So here secant x square means secant x into secant x. One of the secant x went outside, one is left over here. Whole by secant x plus tan x. Now both of them gets cancelled. Now secant x is the result. So how did I do the derivative of this function? By following chain rule. Chain rule means just you have to derivative this one by the standard result. It is not x. Again you have to follow the chain rule like this. One more function I give you. F of x equal to sine of 2x plus 3. Now do whose derivative? F dash of x. Sin x derivative cos x. 2x plus 3. Sin x derivative cos x. Is this x? If it is x, we could leave as it is. But this is not x. Hence it has to be derivated. D by dx of 2x plus 3. Now cos of 2x plus 3. Now 3 derivative 0, x derivative which becomes 1, 2 is left. Now 2 cos 2x plus 3. So that is your required result. Okay students, see this question. F of x equal to a power x, a power x, a power x, where a is positive. How do you do whose derivative? F dash of x is equal to, this has to be treated as x in your brain. Then a power x derivative, a power x only. But is this x? No. Again follow the chain rule. A power x. Now a power x derivative, a power x into log a. Okay students? Right. Now I am giving you one more function. F of x equal to log of sin x. Now f dash of x is how much? So treat this as x in your brain. Then it will become log x. Log x derivative 1 by x. If you treat this is x, then it will become log x. Log x derivative 1 by x. Is this x? No. D by dx of log of sin x. Now 1 by log of sin x. Now log x derivative 1 by x. In the place of x, sin x is there, 1 by x. But is this x students? No. Again it has to be derivated. So do it. So here log x, sin x derivative cos x. Cos x write in the numerator. Come to the down. Log of sin x into sin x. So like this you people have to do the derivative of a function by the chain rule. Okay students. Now let us go to substitution method of derivative. Substitution method. Substitution method of derivative of a function. See students, how do you do the substitution method? So in which the function will be given to you like this. F of x equal to tan inverse of root of 1 minus x by 1 plus x. 1 minus x by 1 plus x. Now do the derivative of this function. In this, substitution is x equal to cos 2 theta, or you can take it as cos theta also. Okay, first simplify this. If you take x equal to cos theta, then 2 theta is equal to, when you transfer cos to the left side, it can be written as cos inverse of x. Now theta is equal to 1 by 2 cos inverse of x. So keep it aside and go here. Now f of x is equal to tan inverse of root of 1 minus cos 2 theta by 1 plus cos 2 theta. Now which is equal to tan inverse of root of 1 minus cos 2 theta can be written as 2 sin square theta by 2 cos square theta. 2 cancel. Now what is left? Tan inverse of root of sin square theta by cos square theta, which becomes tan square theta. Square root to cancel. Tan inverse of tan theta. Now which is equal to theta. So what you have got? F of x equal to, students. So here theta you got. Theta means what? 1 by 2 cos inverse of x. Now find whose derivative? F dash of x, 1 by 2. What is the derivative of cos inverse of x? Minus 1 by 1 minus x square. So that is your required answer. Now I have evaluated by the substitution. Here what substitution I have taken for x? Cos 2 theta. Right, now let us see one more example. F of x equal to tan inverse of 2x by 1 minus x square. Now do whose derivative. So here substitution is x equal to tan theta, students. If you take x equal to tan theta, now f of x equal to tan inverse of, now here 2 tan theta by 1 minus tan square theta. Now which is equal to tan inverse of tan 2 theta. So which is equal to 2 theta. Now f of x equal to 2 theta you got. F of x equal to 2 theta you got. Now f of x equal to 2 into theta. Theta means what? Transfer this tan to the left side so that you will get theta is equal to tan inverse of x. So theta is equal to tan inverse of x. Now go for derivative of this. F dash of x equal to 2 by derivative of tan inverse of x, 1 by 1 plus x square. So now we have prepared whose derivative. I hope you have understood how it is evaluated. Now let us go to logarithmic type of derivative of a function. Logarithmic type of derivative of a function, or logarithmic differentiation. Logarithmic derivative. Logarithmic Now a function is given like this. F of x equal to x power x, where x is positive. Like it is a power function. Base is a variable, power is variable. Base 1 function, power 1 function is given. Now for this type of power functions, we follow logarithmic type of differentiation. In this type, so we apply log on both sides. If you apply log on both sides, log of f of x equal to log of x power x. So log of f of x. So apply the power of logarithmic formula. You know the power formula in the logarithms. As per that power of logarithm, this x will come over here. Now it can be written as x into log x. So base nothing is there means e. You know in the logarithms, log x with base e in some textbooks, ln of x they write like this. ln of x means natural logarithms. Now after this step, do the derivative on both sides with respect to x. If you do the derivative with respect to x, so your log x derivative 1 by x. But is this x, students? No. Hence follow the chain rule. F dash of x. Now which is equal to, this is u, this is v. Now u keep aside and do the derivative of log x. Log x derivative 1 by x. Now plus this log x keep aside and do the derivative of x, which becomes 1. X cancel. Now send f of x to the right side. So now f dash of x, which is equal to f of x into 1 plus log x. Now f of x value x power x. F of x equal to x power x 1 plus log x. Okay students, I think, I hope you have understood. F of x equal to x power x into 1 plus log x. So that is the required derivative for this given function. Now let us see one more application based on this power of one function. See, f of x is equal to tan x whole power sin x is given. Now find whose derivative. Same like previous one. Apply log on both sides, which becomes log of f of x, which is equal to log of tan x whole power sin x. This is the first step. In the second step, as per the power of logarithmic formula, this will come over here. Sin x into log of tan x. Now do the derivative on both sides with respect to x. Log x derivative 1 by x. Is this x, students? No. Follow the chain rule. F dash of x. This is u, this is v. Now keep sin x outside. Now do the derivative of log x. Log x derivative 1 by tan x. Log x derivative 1 by tan x. In the place of x, tan x is there. But is this x? No. Follow the chain rule. Sec square x. Now keep this log of tan x outside into sin x. Sin x derivative cos x. Okay students, now f dash of x is equal to, so shift this f of x to the right side. F of x is nothing but tan x whole power sin x. So here what do you get? Sin by cos. So sin cancel, cos x will go into the numerator. 1 cos x into 1 secant x, 1. So secant x will be left here after simplification of this. So sin by cos, sin cancel, cos will go into the numerator. 1 cos into 1 secant, which becomes 1 secant will be left. Plus cos x into log of tan x. So this is the required derivative of this given tan x whole power sin x. Right, now let us see one more application based on this logarithmic type of differentiation. See students, if x power y, which is equal to e power x minus y, then dy by dx equal to how much? This is the given question. Now tell me students, how do we do the derivative? So take this and apply log on both sides, which becomes log x power y, log of e power x minus y. As per the power of logarithm, y will come over here, y into log x. So this x minus y will come to the left side. Log e with base e, which becomes 1. Y log x, which is equal to x minus y. When you bring a minus y to the left side, x equal to y plus y log x. Take y common. If you take y common, Now x equal to y 1 plus log x. Bring this one to the left side. Now y is equal to, so x by 1 plus log x. Okay. Thereafter you have to follow the u by v rule. Dy by dx equal to, this is u, this is v. Now v keep aside 1 plus log x. What is the derivative of u? Which becomes 1 minus, keep x outside, u. Do the derivative of v. 1 derivative 0, log x 1 by x by 1 plus log x whole square. X cancel. 1 cancel. What is left? Log x is left. Therefore, dy by dx which is equal to, so log x by 1 plus log x whole square. Okay students, so this is your required derivative of the given function. Okay students, now let us go to the parametric type of derivative of a function, or parametric type differentiation. Parametric type of derivative of a function. See in which students, like a function will be given to you like this, x equal to at square, where a is a constant, y equal to 2at. Then find dy by dx. These are what? Parametric equations. And asking us to find dy by dx. In this type, see here, x is a dependent variable, t is independent variable. So first you have to evaluate dx by dt. So here a is a constant, as I said to you. You have to derive to t. So 2at you will get. Because you know, d by dx of x power n, which becomes n into x power n minus 1. N into x power n minus 1. As you have studied. Okay, I think your physics sirs also might have taught. So fundamental principle, derivative of x power n which becomes n into x power n minus 1. So here t square you will get 2at. Then what about to dy by dt? t1. So 2a you will get. Now you want to dy by dx, which should be written as dy by dt by dx by dt. So dy by dt is 2a, dx by dt is 2at. 2a cancel. 1 by t is left. Okay? Right. Now, let us go to one more application. See, y equal to e power t plus cos t. Now, x equal to log t plus sin t. Now, two parametric equations are given. Here parameter is t. Parameter is t. Same like previous one. So what you have to do? dy by dt you have to do. So e power t derivative e power t. Cos t derivative minus sin t. Then what about to dx by dt? 1 by t. So sin t, cos t you will get. Now we people requires dy by dx. For this you have to divide this by this. So 1 by t plus cos t whole by e power t sin t. If you simplify this, you will get 1 by t into, so in the numerator 1 plus t cos t, in the denominator e power t minus sin t. This is your required derivative of that function. So this is, students, what it is? Derivative of parametric functions. Now let us go to derivative of one function with respect to other functions. Derivative of one function with respect to other function. So here two functions are given. F of x equal to e power x, and second function g of x equal to root x. Now the question is, do the derivative of this function with respect to this function. Do the derivative of this function with respect to this function means f dash of x by g dash of x. Now f dash of x, do the derivative of this e power x. Do the derivative of this 1 by 2 root x. Root x derivative is 1 by 2 root x. Now this will go into the numerator so that you will get 2 into root x into e power x. Okay, like this you have to do derivative of one function with respect to other function, students. So here e power x f of x, g of x sin x is given. Now do the derivative of this function with respect to this function means it has to be do the derivative separately, and it has to be do the derivative separately, and afterwards this by this you have to divide. What is the derivative of this f dash of x? E power x derivative e power x only, but this is not x na. Again you have to follow the chain rule so that it gets cos x. Now derivative of this sin x derivative cos x. Now both gets cancelled. What is left at the end? E power sin x. Okay, students? Right. Now this is okay, derivative of one function with respect to other function. Now let me explain you derivative of implicit functions. Implicit function means, see, function will be given to you like this in terms of x comma y. Like you can take x square plus 2xy plus y square minus 3x plus 4y plus 6. Okay, a function is given like this and asking us to find f dash of x. If you take this is y, then find dy by dx. Okay, this is implicit equation which is equal to 0. Implicit equation. Implicit equation. You can't able to split into x. Okay, x is one side and y is one side. There are two variables x and y. Can you able to make x as subject and y as subject? You cannot split. You can split, but it is difficult. So in this type of equations which contains two variables or more than two variables, okay, mostly they will give you two variables only, because here two-dimensional curve only, that is x and y, two variables you will find, so that it has to be derivated. How means? By following this derivative of implicit equations concept. There is one shortcut and a regular procedure. Two procedures I explain you, but in the exam whichever you feel you can apply that method. Every time algebraic function need not be given. In this also they may give you other functions like sin, cos, tan, log. Okay, students, but I took an algebraic function. Now I am going to find whose derivative. Okay, very easy only. See, first I will follow the regular procedure. So x square derivative 2x. This 2. Here xy. Here this is a u, this is v. X into y derivative dy by dx. Y keep aside. Do the derivative of x, which becomes 1, plus y square derivative 2y into dy by dx, minus x derivative 3 plus y derivative 4 into dy by dx, constant derivative 0, which is equal to 0. Okay, students, now here, so 2x, if you send 2 inside, 2x dy by dx. Now if you send 2 inside, 2y, so here 2y dy by dx, so minus 3 plus 4 into dy by dx, which is equal to 0. Now from these three take dy by dx common. If you take dy by dx common, so here inside 2x will be left, here 2y will be left, plus 4, and remaining all of them send it to the right side. If you send right side, 3 minus 2x minus 2y. But we people requires this. This we don't want. Send it to the right side. If you send it to the right side, you will get dy by dx is equal to, students, 3 minus 2x minus 2y by 2x plus 2y plus 4 you will get. I hope you have understood this. But this can be done by partial derivative also. Partial derivative. So partial derivative means in which, so we do by this formula, minus dou f by dou x by dou f by dou y. This is the formula. Okay, students. So you may ask me, what is meant by minus dou f by dou x? Means while doing the derivative of this function with respect to x, you people have to treat y as constant. See, minus x square derivative 2x. Okay, students, we are doing with respect to x na, y is constant, x derivative 1. So here 2y will be left. So y constant, whose derivative becomes 0. Here x derivative 1 minus 3. Here y is constant, derivative must be 0. Constant derivative is 0. Whole by. Here in the down, dou f by dou y. You have to do the derivative with respect to y, which means that x should be constant. X constant means here, so this is going to be 0. Now y derivative 1, so 2x will be left. So here 2y. So here, students, constant derivative 0. So here y 4, constant derivative 0. Now minus of 2x plus 2y minus 3 whole by, so 2x plus 2y plus 4. This is your required result. Okay, students, I hope you have understood this. Now let us go to the higher order derivative. Higher order derivative means we do the derivative of the function more than once. dy by dx. If you do the derivative one time, that will be called first order derivative of the function. If you do more than 2, then that will be called higher order. You may do twice or thrice or n number of times. But in the competitive exams, up to they will give you second order only. We have second order derivatives only. Okay. Now let us see one application based on that. So y is equal to x power 4 tan x is given and asking us to find y double dash. Y double dash is equal to how much? Means it has to be derivated twice. 2 times you have to do whose derivative. Now let us see first time. dy by dx, which is equal to x power 4 derivative 4x cube tan x derivative sec square x. Now do one more time. One more time means d by dx of dy by dx. So this is the notation. Now it should be written as d square y by dx square, which is equal to 3 4s are 12, 12x square. Now sec square x derivative 2 into sec x. Is this x, students? Not x. Then follow the chain rule. Sec x into tan x. You will get like this. So this is the second order derivative for the given function. Now let me explain you one more application based on this higher order. See here, if y is equal to a into e power nx plus b into e power minus nx, then show that y double dash is equal to n square y. So now tell me, students, how you have to prove this one equal to this. So your y double dash they gave, which means that we have to do twice whose derivative, dy by dx. Now a into e power x derivative, e power x only. Is this x? No. Follow the chain rule, you will get n. So b into e power minus x minus nx, derivative is e power minus nx Again follow the chain rule, you will get minus n. Now do one more time, d square y by dx square. So here an is outside and e power x derivative e power x only. Is this x? No. Follow the chain rule, n will come. Plus into minus minus bn e power minus nx. Is this x? Not x. Follow the chain rule, minus n. Now simplify. N into n, n square. N square a e power nx. This minus into minus plus. So here b n square e power minus nx. So from both of them take n square outside. If you take n square outside, a e power nx. So here b into e power minus nx you will get, which is nothing but y. In place of this y, write y, so that you will get n square into y. This is your required result. So here y double dash is equal to n square y, you got no? I hope you have understood. This is a basic differentiation class. So in this class I gave you the meaning of derivative of a function. Then how we have to evaluate derivative of a function by the first fundamental principle of derivative. Then doing the derivative of this function is so difficult for all the functions. Hence we people have to follow the methods of derivative. Under that methods of derivative of a function, I explained you UV rule, U by V rule, U plus or minus V rule, chain rule, substitution method of derivative of a function, and a logarithmic type of derivative of a function, parametric type of differentiation, and a derivative of one function with respect to other function, and how to do the derivative of implicit equations and higher order derivative. All these models I have covered. So for more regarding this derivative classes, so follow my future classes in which I am going to teach you like MSET level and mains level and advanced level classes for this differentiation, because this is very very important in the competitive exam point of view. If you are expertise in this differentiation, then you feel that applications of derivative as easy, and indefinite integration, definite integration and differential equations all you get in the easy manner. Unless you are expertise in the doing the derivative of a function, so you can't able to get other chapters. So hence you people have to concentrate more on this derivative of a function. I am requesting you to subscribe, like and share my channel so that my classes reaches to many people, students. Thank you students. This class here itself I am closing. Thank you one and all.